I've had this tracked DPM forever, and it uses Cat 40 tool holders, and this is my current tool holder organizational method, which was okay when I had just a few tool holders, but lately I've been getting some jobs where it really pays to have some additional holders so that I don't have to be changing tools in and out of the holder that often. So today I'm going to tackle making a board to mount on the wall right here behind the machine, and have a setup for, I guess, 24 Cat 40 holders. So this is also a chance to do some taper boring on the mill using a tree taper boring head. Like all projects, you start out thinking, what do I have around that I could use to create what I'm after? And I had some bench tops left over from these Craftsman benches that are around the walls here, and it's 1.5 inch MDF, and I had one left over where I put a cast iron top on one of the tables, and so this was just about perfect for what I was after. I'm going to bore tapered holes that match Cat 40, 6 of them across here. This was the original width of the table or the bench top, and then I liked, because I need more than just a single row, I don't have to walk all over the place, so I'll be able to just turn around at the mill and reach for these. I thought, well, I'll stagger these such that the next one on the wall, this clears so that you can have longer tools and not have to have these, you know, long enough to be able to reach straight up. If I put them straight and you put the next one above, you could run out of room here. So this way you could have super long tools and it won't matter. They'll be on there. And initially I'm thinking, okay, I've got my little wedges cut out of the same stuff, and I'll space them right in between where the holes are. But then I'm going to have to put a hole through here and try to hit studs, the 16-inch stud spacing on the walls and all that. And I'm thinking, oh, I'm looking at the walls, and I'll move these to the correct stud spacing. And finally I realized, you know what, this is nuts. Just mount these on a entire board, being able to screw anywhere I want from the back. Mount them in their positions and spacing. Be able to glue them onto this, get a really good bond, use some Gorilla Glue on these, and bond them and screw them together. I can just mount this whole board, and I could care less. All I could do is find wherever I put it, mount my stud lines, and run a few rows of heavy drywall screws to hold this thing to the wall. And so that's where I ended up. And what I'm going to do now is actually drill and bore these holes, and we'll get the tree tapered boring head out. And since this isn't really critical, I could go over in the CNC and move and get fancy, but that's kind of a waste of time. I'm just going to put a real thin magic marker line on these at the correct locations, put a witness mark on my vise, and literally just move these by eye clamp, because it's not critical, and why waste time getting all crazy with the other stuff. And we'll start by drilling. Might step drill this, depending, so I don't have to take a lot out with the boring head, and we'll go from there. So put the apron on, and we'll fire up the Bridgeport. Just a little sanity check here to make sure the angle that we got off the internet jives with what these things physically look like. So I'll take a quick look at this thing. 16 degrees, 40 minutes, 16 degrees 40, and so that sounds about right. So my trusty old HP here has a under the time menu has a conversion from hours, minutes, seconds to decimal, and vice versa. So I'm going to type in the 16.4 for 16 degrees 40 minutes, and obviously we're going from hours, minutes, seconds to decimal. And it comes up to 16.6666 on and on. 2 divide for the half angle, which is on the drawing. And the angle I got off the internet was 8.2978 degrees. So plenty close enough for what we're doing in MDF for a tool holder. So I'm laying out Just a pencil mark on here for the locations where I'm going. I realized that pencil would probably work better on these than a fine Sharpie, because fine Sharpie is going to bleed. So I just got these stacked together. I'm just going to draw a line across all of them for my reference. That's what I'm just going to line up with my witness mark on my vise jaw for spacing these. It's quicker than cranking to coordinates anyhow, so for this kind of work, it's going to work well. Okay, got our witness marks on there, and put some parallels in the middle. Go to town. I'm going to wipe the vise down here with some alcohol. We don't want to get oily residue on the MDF as far as for gluing purposes. So, and also for the all the sawdust sticking to the oily surfaces. So I'm just degreasing this a little bit, and we'll put some parallels in with rubber bands. Just need enough for the tip of the drill to poke through, and it's going to be in the gully anyhow, but I'll center it in the vise here. So there, we're set. We'll put our mark on here with the magic marker, Sharpie, for our center line that we're going to line up visually with our marks. Get a good dark line there. And these pieces are just going to set in like this, and we're just going to line them up by eye on each location. And we're going to drill with an 1.5" drill first, part way down, and then an 1.125" drill through. Here I'm picking up on my line to make sure that I'm actually lined up with my spindle center lines actually on the mark across here. Then I have a pencil line in the middle here that I'm going to just visually touch down on and get centered up that way. Look at my drill spot and just move it around until I'm centered there. Okay, I like that. And then we're going down to .850 deep from the touch. So I'm just going to see where I am here. I'm going to call that 0 on my digital. It's going to go 0.8 deep on these. To the next one. And a lather, rinse, repeat on all those. I'm taking a real heavy feed, real slow feed rate to minimize the amount of dust I'm generating. I'll drag the vacuum over here and suck all this up. So here it is, tree boring head. This whole plate swivels. You can see your degree setting here on the side. The mount, this came, when I bought this at an auction, this came with a huge taper shank. and it's hard, solid hard all the way through. So I abrasive sawed it off. Obviously I took it out of the holder. I abrasive sawed it off, and then hard turned it to a 7/8 diameter, a relief to clear the collet nose, and then this bears on the nose of the mill spindle, similar to what Tormach does. They didn't invent that method, they just used it. So that gives you a very rigid coupling, but as the collet pulls back in the process of tightening, it puts pressure on the face here, similar to the way HSK works, HSK holder works. So that's how we got the mount there, nice and short and compact. This works with a rack and pinion. This is a got some sawdust here. It's got a two-stage nut here. This is just an outer cap. Once you loosen it, then you drop the wrench in further till you engage the hex. Then you have full control of driving this wherever you want it, rapid, to go wherever you're trying to get to, like that. So, and you can see it actually drives with a, let me get my wrench out of here. It drives with an actual gear there in the center. And that's what spins. It goes down through and turns that gear, and so it's an actual rack and pinion drive in this particular section here. But it makes for really nice to be able to just back up quickly when you're done a bore. You release the nut, get to where you want to go, and then just tighten the outer shell nut like that. And then as this turns in this direction going forward, this will feed down. This is all hardened. This dovetail plate here is hardened, and then it uses a tapered cone. This is hardened also. These different adapters. There's two for boring bars, and then there's one that has an actual bore for using like round boring bar shanks. And I have some reducing sleeves that I use on there. So I don't use it very often, but when you need it, it comes in very handy. So this goes on with a nut and washer, and it's a nice fit. It looks rough, and it is rough, but it's hardened, and the important parts are finished nicely. So, and that's how you adjust your size. Like when you're taper boring, you literally have no control over this other than what you do here, or adjusting your depth. So depending on what you're doing, that can be tricky. So you can use this for facing off. You can turn this a full 90 degrees and use it for facing or anything in between. Here's a tool I ground up just out of a chunk of solid carbide. Little back rake to it. It's cutting in this direction like this because the way that it sits in the holder. I've got the top rake lapped. Actually, all the cutting edges are lapped with 1 micron on the ceramic lap. You can see it's mirror finish on there. It's like a micrometer anvil face, and the actual cutting edges are lapped like that also. So it should cut pretty well. This thing feeds at 5 thousandths per revolution. And that's why I've got a pretty generous radius out here to kind of bridge that. Not that it has to be any kind of spectacular finish, but we don't want it to look too ratty. One important thing to keep in mind when you're boring with this is making sure this is the angle we're on. We're sitting like this, angled this direction. We want to make sure that we have our cutting tool on that side. You could not be thinking and just put your tool over on this side, and you'd end up with not what you want. You'd actually be boring a taper the opposite direction, which at times may be what you're after, but in this case I want this to taper this way. I want a V. This is the top surface, and we're going to cut this to gauge line on the Cat 40 is 1 3/4. The line right here, right where the taper stops. So we're going to try those in and out. I have the digital zeroed in my eyeball location so I can come back to this, move over to the side to check, and then fortunately I do have enough room, and the tip of this is going down in the gully. So another one of those important things to think about when you're setting up. I did put higher parallels in. One reason for the higher parallels is that I'm going to put my vacuum hose right in underneath here and suck the chips, hopefully, right down through the bore, right as I'm working. So right underneath here, keep it there, and because I'd like to use a reasonable speed here. Okay, so I have my tool here where I'm have this, the outer nut, you just go in about 1/8 of an inch here on the back, and this outer cup style nut, and then you go into the inner one, and this is what drives this up and down. So I'm coming all the way to the top, locking there. Now it's going to drive when I hold the ring. I've got my initial setting here, which I think is going to be okay for, might be a little big, so I'm actually going to adjust this, and literally just, it's just a pivotal adjustment of size there. So I'm going to go, this, since this is 1.5 inch hole, I'm looking at roughly 1/8 inch of cut. That's in the ballpark right there. I'm just going to take a cut and see what goes on. Sorry for the vacuum noise, but... Okay, now when I retract, I just loosen my nut, put my wrench through, and crank her back. Pretty sweet setup. Now I'm going to measure here, just with scale, and I got another whole 1/16 of an inch to go here. I want to take this in one cut. I don't want to be fooling around here, taking rough and finish and all that. I'm kind of a crash and burn kind of guy when it comes to getting the job done. And so I'm going to run this down until it's closer to the surface. Loosen my nut, drive down here, and picture my, what did I say I need here? Another 1/16. So I'm going to picture my 32nd of an inch there. Visual. And the other thing you can do adjustment-wise, once I'm in the ballpark, we can adjust with our height. So I only got to get close here, and then I can fine-tune. Okay, I'm going to leave it there, and we're going to go from, I have my digital Z zeroed here so that I can make fine-tune adjustments there for up and down. Now, remember to take the wrench out. So I'm going to actually drive down until I'm ready to cut, slide back into the outer clamp nut. We're going to go all the way through this time. That's pretty cool. Ooh-wee. I'd say we're there. I'm going to crank off now, and so I can stick my holder in. Oh, that's nice. I have it intentionally. When I set the angle setting, I intentionally made it so that it was going to hit on the gauge line first. In other words, if it's going to err on my angle, I was going to make it so that it's hitting on the top, not at the bottom. So there's room at the bottom for the tail to wiggle around a little bit, but I'm not trying to nail this thing. I mean, this is plenty good enough for what we're doing. We're just dropping a tool in there, and it's nice and protected. Now I'm deeper. Oh no, I got an 1/8 inch there. I'm just going to raise that up about 30 thousandths so that I don't have any issues with tools that might have a closer gauge line. So I'm just going to go on my digital here, raise the entire head up about 30 thousandths and re-zero it. And keep in mind now, this quill motion directly affects the location of the taper and obviously affects the diameter at the face here. So that's good to go. We're going to move over to another one. The vacuum through the bottom is working marvelous. And so I'm just going to come here, line up with my pencil line again, like we've been doing. Come back to my 0 here. And you'll notice I was starting to get a little chatter and little howl as I get through there. And that part of that's because this thing isn't like super heavy duty. You look at the proportions of the this plate. Isn't all that beefy, so and at the bottom it's taken almost a full 1/4 inch full face of the tool down here. So now I'm going to lock my outer cup nut there and go ahead and fire up and go down through. I found, you might have noticed the little shake in the camera, and that's when I said, oh, let's try a little faster. And obviously the limiting factor on this is the out of balance of this thing, because you got this one big huge side that's there. So they didn't need to put a warning on there, because anybody in their right mind is going to find out real quick what's too fast. Okay, we're back with putting the part back in where we had done these first 3 with a single pass. Roughed all the other ones now with the roughing pass. I'm just going to go over and give my tool just a little lick on the lap for the finish cut. Probably doesn't need it, but I'm going to go over and do it anyhow. Okay, that thing's crazy sharp. It's definitely going to give us a nice cut. This should behave a lot better now with a reasonable cut. I also actually tweaked the gibs, re-lubed the slide and everything, and tweaked the gibs a little bit. I'm just going to actually come out and sweep into the cut. Okay, get a little better vantage point here for watching this go down through the bore. Going to turn the vacuum on. Just a little tooling note. Originally, when I was cutting before, I had the nose of this tool was square. It was squared off on the end, which left a very large lead angle, so almost a full 1/4 inch of engagement of lip of tool, which makes for a lot more loading, a lot more chance for chatter. So I just whacked the tool off here at so that the lead angle is minimal, basically square to the direction of cut, and just the nose radius on there. I'm going to see if that gets rid of some of that howl. So that was a good lesson there in paying attention by getting rid of that very, very long cutting lip, and because it had a very shallow lead angle in the cut, and squaring it up so that it had minimal length of engagement in the cut. Got rid of the noise. So we'll do one here. I hope you can hear it over the vacuum. go. I don't know why I said hope you can hear it over the vacuum when I'm shooting for silence. But yeah, no noise, no howl at the bottom. So good lesson for everyone about the length of cutting lip relative to chatter. Here's the drawings that were in this. Obviously I got this in auction quite a long time ago. But here's an actual drawing where they measured all of the parameters for the actual fit of how this attaches inside the boring head. This is actually the adapter that I mentioned that I whacked off and hard turned all this to fit the 7/8 collet with a facial contact. Here's another one that they had in there, was the another adapter, and obviously this was to go on something else they had. And the 7/8 14 thread is the thread that's in the boring head, and then it pilots on these two diameters in the face there. They've got these ground. And then here's the instructions. I really should make a scan of this and clean this up, but everything's still legible here. This is the actual instruction manual. Shows you all the different lubrication, taper boring on this side, straight boring, facing, outside turning. Straight boring, you can actually set that at 90 degrees, and then each division on the outer dial is 1/10,000th of an inch on diameter. So I'm not sure how well that would work since it's kind of a rack and pinion drive, but never really tried it because I have another boring head that's better suited for that. But just interesting piece of equipment, and I thought you guys might get a kick out of seeing it in operation. An interesting design note on this is that the taper that they ground on the inside of this that holds that bar in position is right on that verge of being a locking taper. It's right on that borderline, so when you tighten it, it actually sticks, but it doesn't stick real hard. So that was a really nice touch to the guys who designed this, is getting that taper at just that right angle where when you tighten that nut that holds it on, this nut right here that locks it on, you don't have to enter into a contest of strength with it to be sure that it's not going to move when you're boring. This thing, because of it being on the verge of a locking taper, really works nice. It's just a light tap with a wrench and it'll break loose. So really, my hat's off to the guys that engineered that. Then here's some bushings that I've made for the this adapter. This is actually the adapter that has the hole in it for boring bars. So these are different size hardened sleeves that I've made for using small carbide boring bars with it.
Using the chamfer meister here to put a bevel on the wood, wrap right around the corners, and just sand a nice bevel on the whole length of this thing. As you can see, it's a really quick way to get a nice chamfer on.
Just using the sanding sponge here to get the flap off the bottom of these holes. Do the same on the top. I'll be using this chamfer mill, 30-degree chamfer mill, ever-ready tool. I'm going to put the bevel on the back edge of the block to get some more glue area on there. So I'm just going to go to the full width of this insert that I can get on there, and just slide it down through the vise multiple times on the Bridgeport.
Everything's set here in the Bridgeport for the location, and just feeding across, stopping when I get to my end of travel, rapiding back, reclamping, and going the rest of the way. Drilling some pilot holes for the angle blocks. Wetting the wood for the Gorilla Glue to go on, and massaging the Gorilla Glue around to get a good spot there to have it uniformly distributed. Drilling my starter holes for the screws that will actually mount these to the board. So these are in strategic locations to match with the holes that are in the board and at the basically root diameter of this. Same procedure here with wetting the surfaces for the Gorilla Glue. I already have my holes in the board lined up, putting drywall screws up through the bottom, and getting the glue on, and using a spatula there to smooth things out, move it around. I just have 2 screws in to go into the 2 end holes that I'm lining up and get them started, and then the other ones all go in from the bottom to pull the whole thing down. You can see where the Gorilla Glue has exuded out there in the corners. I scrape that off before it gets real hard. Well, it's easy to remove. Finally mounted to the wall and have the holders mounted in there and ready to go.